Good evening. So, in this lecture, I'm going to talk about the pressure due to fluid. Topic is pressure due to fluid under gravity. This is our topic. So, to understand this topic, let us take a situation here. Let us assume that this is your floor. Okay, so on this floor, there's a one container like this. We have drawn a container. Now, this container is filled with some liquid. Okay, let us call this density of the liquid as rho. So rho is the density of the liquid. In this question, we have also assumed, in this situation, we assume that atmospheric pressure is zero. So there is no atmospheric pressure. So pressure is zero outside. All right. Also, we have to assume one more thing, that acceleration of this container is zero. That means this container is at rest. So these are the some of the assumptions that we are making here. Now, our challenge, our task is to find what is the pressure difference between any 2 points inside the liquid. Let us suppose this point is A, this point is B. So what is the pressure difference between these 2 points? Because of the gravity, there should be some pressure difference. Let us assume the gravity to be downward. G meter per second square is the acceleration due to gravity. Now, because of this gravity, what happened that you see at this point, this much amount of liquid is available above the point A, so there should be some pressure. If you consider this level, uh, more amount of fluid is available above the point A. So because of the weight of that fluid, there will be also some pressure at point B. So you have to find what is the pressure difference between these 2 points. There is pressure, no doubt, because of the weight of the fluid. There is a pressure at point A also, and there is a pressure at point B also. But what is the pressure difference between these 2 points? Okay. So let us also assume that this difference between the point is given as H. Okay. So this problem can be solved if you just imagine a small cylinder here. Okay, this imaginary cylinder is also made up of the same density as the fluid. So if you imagine this small cylinder, let me make a small cylinder here. This is your small cylinder. And if I'm going to analyze this, all the force on this small cylinder, then we can find the pressure difference between 2 points. So the height of the cylinder is H, and let us suppose that this area, cross-sectional area on both sides of the cylinder is S. Now you can take any shape of the body, but I'm taking cylinder for uh, easy visualization. Okay, so S is the cross-sectional area. If you look at the top part of the cylinder here, this part, there is a pressure. What is the pressure? Pressure at this point is, say, PA. So this is the pressure here, PA. And at the bottom part, pressure is PB. Now, because of this pressure, there is a force acting on the top part of the imaginary cylinder. Okay, there is a force acting on the top part. So what is the value of that force? you know that because of pressure, there is a force that is acting perpendicular to the surface. This force will be pressure at this point into area. Area is S. So on the top part of the cylinder, the force due to pressure will be PA into S, where PA is the pressure at the top point. Now, if you look at the bottom point, there is also force acting perpendicular to the surface. This is the force acting perpendicular to the surface, and the value of this force will be PB into S. Let us call this F1 and this is F2. So these are the two forces acting on the top and the bottom part of this imaginary cylinder. Okay, there is another force that is acting on this particular cylinder, small cylinder, and that force is its own weight that is acting downward, mg. The weight is acting downward. Now you can write mg, you can write mass in this particular cylinder case. You can write the mass as density into volume. So density is rho and volume will be area into length of the cylinder. So cross-sectional area is S and length of the cylinder is h. So you can write h. This is the volume and this is density. So density into volume will be mass, okay, times gravity, g. So we have written all the forces, external forces acting on this small cylinder. Now this particular diagram is called free body diagram of this small cylinder. So free body diagram in which we draw all the external forces acting on the body. So this is the free body diagram of this small section of the cylinder. Now if you look at carefully, since the container is not accelerating, so this particular cylinder that we have taken, it is also not accelerating. That means it is the condition of a static equilibrium condition. In this condition, we know that sum of all the forces should equals to mass into acceleration, but acceleration is zero, therefore sum of all the forces should be zero. So if you do summation of all the forces, so let us do the summation here. So first of all, this force is acting upward, so we will take it positive. So any forces that is acting upward, we will take it the value positive. So this will be PB into S. Now this mg is acting downward, so we have to take the value negative, and also the pressure that is acting on the top part of this small cylinder is also in downward direction, so we have to take the value negative. So Pa into S minus rho Sg. So we have summed up all the forces. So whatever the forces acting upward, we have taken positive, and whatever the forces that is acting downward, we have taken it negative. Why we have done this? Because we know that force is a vector quantity. This should equals to 0 because the container is not accelerating. So uh, if you do this task and if you solve this equation, you will get some interesting result. So in this equation, we can see that S is getting cancelled and we are getting PB minus PA minus rho GH equals to 0. Therefore, you can write PB minus PA equals to rho GH. So this is the pressure difference between any 2 points inside the liquid. Now this equation says that, you see, the difference comes out to be positive. This difference is positive, right? It means that PB is greater than PA. So PB is greater than PA. That means pressure at point B is more as compared to point A. This is justifiable, no? Because you see, above the point B, there are more fluid as compared to the fluid above the point A. Okay, so naturally the pressure at point B should be greater as compared to point A. Now this equations is very important in terms of solving problem. That is, between any 2 points, the pressure difference between will be rho gh, and the pressure that is at more depth will be more. Okay, So pressure at more depth will be more. To sum up all this together, I can draw one simple diagram that suppose pressure at this point is P1 and you are going downward. So if you move downward to some height h, so pressure at the depth increases. So at this level, the pressure will become P1 plus rho g h. Okay. If you move from this surface number 1 to surface level 1 to level 2, if the pressure is P1, at this point pressure will be P1 plus rho g h. So that you can whenever you take so that when you take the difference, it will come out to be rho g h. On the second hand, suppose here pressure is, let us say here is pressure, now suppose here is pressure P1, this is layer 1, layer 2. Now you are moving upward. If you move upward, then pressure will decrease. So here at this level, pressure will be P1 minus rho g h. So again, when you take the difference between these two levels, it will come out to be rho g h. Okay, so this is the story of pressure at pressure difference at any 2 point inside the liquid due to gravity. Okay, so this is a very interesting topic in fluid mechanics. But if you know this topic, you can solve n number of problem. Okay, thank you.